Hi everyone, welcome to a new video. Today we'll be talking about how to solve a system of linear equation in two variables, and we'll discuss the elimination method. So in this video, I'll first explain to you what do we mean by a system of linear equation in two variables, and then I'll explain to you the general procedure that we'll use to solve this kind of system of linear equation using the elimination method, and then we'll go through several examples. And these examples contain some basic example, and also it contains one example to deal with a equation that have fraction, and one example when there is no solution. So how to recognize when actually there is no solution. So stick around and let's get started. First, what do we mean by a system of linear equation in two variables? What this means is that you have two equations. For example, you could have x plus y equal to 6, and another equation, something like x plus 2y equal to 8. And what we are trying to do is to find the value of x and y that satisfy both of these equations at the same time. In this video, we'll see what we call the elimination method. So the step to solve this using elimination method is as follows. So the first step is to write the two equations in the standard form. What that means is that you need to make sure that the variables are on the left and the constant terms on the right. Also make sure that the variables are written in the same order. So for example, you have x, then y. The second equation should also start with x, then y. The next thing is to choose one of the variables to eliminate. So here, since we have x and y, you need to pick one of them, either x or y. Also, it doesn't matter which one of the two variables you choose. If you pay attention, sometimes choosing one variable will make it much easier and faster. So we'll discuss this in the examples, how to pick the variable. The next thing is to make sure that the coefficient of the chosen variable are opposite if they are not already. For example, let's say if you choose y, we can see that the coefficient for y in the first equation is 1 and in the second is 2. It's not the same. So in this case, we need to make sure that the coefficient is the same by multiplying 1 or sometimes both of the two equations. And we want the coefficient to be the same but opposite sign. So in one equation, for example, it is 2, in the other one should be minus 2. So again, through the example, I'll explain how can you do this. After that, you will add the two equations, and this essentially will cancel one of the two variables, and you will remain with only one variable. So then you will find the value of that remaining variable from the equation that you get after you adding the two original equations. Once you find that variable, let's say you find y, then you go and try to find the value of x. And this is simply by substituting the value of y that you find in one of the original equations. And that will give you the values for x and y. And you can verify this by substituting the value that you get in both of the original equations. So if you substitute the value that you get in the original equation, they should satisfy these two equations. So now let's take some examples. Okay, so example. Let's say we have the following system. 2x minus 2y equals to 6. And then the other equation is 2y plus x minus 9 equal to 0. So we have these two equations. So our first step is to make sure that they are in the standard form. Now we can see we have a problem with the second one. The constant is not on the right hand side. And the other thing we notice here is that also the order of the variables are not the same. So in the first equation, we're starting with x, then y. In the second one, we're having y, then x. So we need to fix this. So what we'll do is the following. So the second equation, we'll start writing x first. And then we'll have to take 9 to the other side. So now we have the two equations. This is our first equation, and this is the second equation. Now, in this case, we want to eliminate one of the two variables, so we need to decide which one to eliminate. As I said, you can pick any one of them, and you can follow the procedure, and you'll find the solution. However, typically we look, do we have any of the two variables already have coefficients that are the same but with opposite sign, because that simplifies our life. If you look in this case, you have in the first equation 2x, and the second one is x. It's not the same value and not opposite sign. Now, if you look at y, in the first equation, it have minus 2 as a coefficient, and in the second equation, it have plus 2 as coefficient. This is exactly what we are looking for. We are looking for a variable that have a coefficient that are opposite. Minus 2 and 2, 3 and minus 3, and so on. So that's great. So we're going to eliminate y in this case. How do we do that? We simply add the two equations. So what we'll do is that we're adding equation number 1 plus equation number 2. What do we get? In the first equation, you have 2x, and in the second one, 1x. So that gives you 3x. When you add minus 2y and plus 2y, give you 0. And then we'll get the constant when we're adding the constants. That gives you 15. Now, this is a very simple equation. What we need to do is to get rid of the 3, and that is very simple. We simply divide by 3 both sides. So we'll get 15 by 3. This gives us 5. So the value of x is 5. How do we get y? Well, we simply substitute the value of x in one of the original two equations. So here we pick any of the two equations. We can pick any of the two equations and substitute the value of x on it. So substitute the value of x in equation 2. If you look here, equation 1 have y with minus coefficient and equation 2 have y with positive coefficient. I prefer to work with positive coefficient. That's why I choose equation 2. However, if you choose also equation 1, that will also lead to the same answer. So in equation number 2, we substitute the value of x. So x is 5 plus 2y equal to 9. Now we need to take the 5 to the right hand side. So then you will get y equal to 9 minus 5, or 2y equal to 9 minus 5 is 4. And then we divide both sides by 2 to get the value of y. So y will be 4 divided by 2, which is 2. So then this is the solution. X is 5 and y is 2. And you can verify this easily if you go to the original equation. So this is the first equation. 2 times 5, that is 10. And here minus 2 times 2 is 4. So you have 10 minus 4 will give you 6. So the first equation is satisfied. If you look at the second equation, you have 5 plus 2 times 2, that is 4. So you have 5 plus 4 give you 9. The second equation is also satisfied. Okay, this is how we verify. Now let me take the same two equations, but this time I'm going to eliminate x, just to show you that it doesn't really matter which one you choose. So let me write the two equations that we have. So the first one was 2x minus 2y equal to 6. And the second one, after we wrote it in the standard form, it was x plus 2y equal to 9. So let me call this equation 3, and this is call it 4. Okay, so now our goal here to eliminate x. In the previous solution, we eliminated y, and then we got x, and then we substitute. Now, to get rid of x, we can see that in the first equation, the coefficient of x is 2. In the second one, it is 1. So we are trying to make them opposite. One way is to make the first one minus 1, or to make the second one minus 2 by multiplying by minus 2. In general, we will go for multiplication. Division may result in fraction, so we don't want fraction. It's much easier to work without fraction. So we'll go with multiplication. So what we'll do here, we'll take equation number 4 and multiply it with minus 2. And then what we'll get is the following. Minus 2 times x, that give you minus 2x plus 2y here. And when you multiply it with minus 2, that will make it minus 4y equal to, you have 9 here, you multiply it with minus 2, that give you minus 18. So we'll call this equation 5. We simply now add the new equation 5 with the equation number 3. So what we are doing here, equation 3 plus equation 5. Remember, 5 is just coming from 4 after multiplication, so it's equivalent to 4. When we add, you have 2x and minus 2x, that give you 0. In other words, it cancelled out. And you have minus 2y and minus 4y. That will give you minus 6y equal to 6 plus minus 18. So you have different signs. We'll subtract 18 minus 6, that give you 12. And since the larger in this case is negative, the final answer should be also negative, so you'll get minus 12. Now, in order to get the value of y, we need to divide both sides with minus 6. When you divide by minus 6, the minus 6 on the left side will go away, so you'll get y. And minus 12 divided by minus 6, minus divided by minus will give you positive. 12 divided by 6, that is 2. So we get the value of y, which is 2. Now, as we did before, we can substitute in any one of the original equations. If you look in this case, look at equation 4, actually you can see that x has no coefficient. So it means when we substitute, we can get x directly without having to divide or do anything. So I'm going to choose equation 4. So substitute. Of course, if you choose also 3, you will still get the correct answer. Except here, get x directly. So you'll have x plus 2 times the value of y2 equal to 9. And then we have x plus 4 equal to 9. We can move the 4 to the other side. So we get 9 minus 4, which give you 5. So we get x equal to 5 and y equal to 2. And if you compare this is exactly what we get in the first solution. So you can see from this example, it really doesn't matter which one you eliminate, you will always get the correct answer. However, we typically try always to choose the easy one. And the easy one typically is the variable that's already ready for elimination. It means it already have opposite values, like we see here. Have minus 2y and plus 2y. So it's ready for elimination. So we pick it for elimination and then we proceed. Let's go for another example. Okay, so our equation 2x plus 3y equal to 4. And the second equation 3x minus 2y minus 6 equal to 0. You can see that the second equation actually not in the standard form. The constant coefficient should be on the right, but it is in the left. We can easily fix that by moving this to this side. So this equation becomes 3x minus 2y equal to 6. So let's call this equation 1 and this is equation 2. Now we can see that here we have 2x, here 3x, here 3y, here 2y. So we don't have any variable with coefficient ready for elimination. So in this case, we will just have to pick one of the two variables. So let's pick y because y have a positive sign in one equation and a negative sign in the other equation. I will not need to multiply with negative value. What we need is to multiply one or both to make the coefficient common. Obviously, in this case, I cannot multiply 2 with anything that will give me 3 unless I multiply with fraction. I'm trying to avoid the fraction. Similarly, you cannot multiply 3 with anything other than fraction to get 2. So again, that's a problem. So what we'll do, we'll look at the common multiple of 2 and 3. So you know that multiple of 3 you have 3, 6, 9, etc. Multiple of 2 you have 2, 4, 6. We can see easily that 6 is a common multiple of both of them. So we'll try to make the coefficient of y to be 6. So how to get that? In the first equation, then we'll need to multiply with 2. So then equation 1, you multiply it times 2. What do we get? We'll get 2x times 2 give you 4x. 3y times 2 give you 6y. 4 times 2 that give you 8. Let's call this equation 3. Now the second equation, we have the coefficient of y is minus 2. In order to make it 6 or minus 6, in this case, multiply with 3. So then we multiply equation 2 times 3. 3x times 3, that give you 9x. Minus 2 times 3, that give you minus 6y. And 6 times 3, that give you 18. So equation 3 and 4 are simply equation 1 and 2 after multiplication. And now we can see that you have plus 6y and minus 6y. Ready for elimination, what we'll need to do is just to add the two equations. So we take equation 3 and add it to equation 4. 4x plus 9x, that will give you 13x. 6y plus minus 6y, these will cancel out. Then 8 plus 18, that give you 26. And in order to get x, we simply divide by 13. So we'll get 26 divided by 13. And that is 2. How do we get y? You can use any equation of the original to get y. So let's substitute, for example, in equation 1. So substitute in equation 1. It's 2x plus 3y. So when you substitute, we'll get 2 times the value of x2 plus 3y equals 2. So 2 times 2, that is 4, plus 3y equals to 4. We move the 4 to the other side. What we get is 3y equal to 4 minus 4, that is 0. Then we can divide both sides with 3 to get y. So y will be 0 divided by 3, that is 0. So y is 0. So then our answer is x equal to 2 and y equal to 0. And you can easily verify that by going to the original equation. So 2 times 2, that's the value of x, will be 4. 3 times 0, that is 0. So we'll get 4, which is equal to the right-hand side. Similarly, 3 times 2 will give you 6, minus 2 times 0, that will be 0. So we'll get 6 minus 0, give you 0. So again, the second equation is satisfied. Okay, so let's look at another example. Okay, so we'll have half x plus 2/3 y equal to 1/2. So this is our first equation, and the second equation, x plus 4y equal to 2. You immediately notice that in the first equation, we have actually fractions. So we'll try to eliminate the fraction. The first step is to get rid of the fraction. And how to do that? We simply need to multiply the first equation with a number that will get rid of the fraction, and that is the least common denominator for 2 and 3. Again, so you're looking for a multiple of 2 and 3. This is similar to what we said here. We're looking for a multiple that is common for both 2 and 3. Why 2 and 3? Because we see that we are dividing here by 2, or here dividing by 3. These are the two numbers. So then we choose 6. We have equation 1 times 6. So 6 times half, or 6 divided by 2, that give you 3x. Similarly, 2 times 6 divided by 3. 6 times 2, 12 divided by 3, that is 4. So you get 4y. 6 times half, or 6 divided by 2, that is 3. So this is equation 3, which is simply equation 1 after multiplication. Now what to do? We need to eliminate one of the variables. We can see here that you have 4y here and 4y here, but we just need them to have an opposite sign. So this is simple. We just need to multiply with -1. So let's say we'll take equation 2 and we're going to multiply it with -1. That will give you minus x minus 4y minus 2. So multiplying by -1 simply will change the sign for all the numbers. And let's call this equation 4, which is equation 2 after multiplying with -1. Now we have equation 3 and 4, and we have y ready for elimination by adding. So if you take equation 3 plus equation 4, you'll have 3x plus minus x, that will give you 2x. 4y and minus 4y that cancel each other, equal to 3 minus 2, that is 1. And so to get x, we simply divide by 2. So then we get x 1 over 2, x is half. And to get y, as we did in previous example, we just need to substitute in any of the equations. So let's say we're going to substitute in equation number 2. Substitute in equation 2. And then what we'll get is that x 1 over 2 plus 4y equal to 2. And from this, we can move up to the other side. So we get 4y equal to 2 minus 1 over 2. I can have 2 as common. 2 times 2, 4 minus 1. That give you 3 over 2. And now in order to get y, we simply need to divide by 4. Or we multiply with 1 over 4 both sides. So here we get y, then you get 1 over 4 times 3 over 2, that give you 3 over 8. And that is the value of y. So we already find the value of x and the value of y. Okay, let's look at another example. We have x plus y equal to 3. This is first equation, and x plus y equal to 2. Again, as we did, we need to decide one to eliminate. In this case, you can see both x and y have a coefficient of 1. So we just need to make them negative. If we decide to eliminate y, for example, we just need to multiply one of the equation with -1. So let's say we're going to take equation 2 and we'll multiply it with -1. Multiplying with -1 will change the sign for all of the variables and constants. So we'll get minus x minus y equal to -2. And this is equation 3, which is 2 after multiplying it with -1. What we do is now to add equations. So we take equation number 1 plus equation number 3. We have x plus minus x, that give you 0. Y plus minus y, that also give you 0. Equal to 3 plus minus 2, that give you 1. This means 0 equals to 1. What does this mean? 0 equals to 1. We know that's not possible. So in this case, if you end up with something that is not true, like 0 equals to 1, then you know that there is no solution for the system of the equation. In this case, actually, the line will be parallel to each other. If we plot these will be parallel to each other and will not intersect. So there is no solution. So that's it for this video. If you find this video is useful, please give it a like and also consider subscribing to the channel and turn notification on to get notified about new content. Thank you for watching.